Hi there. This video is an exam paper walkthrough of the Eduqas GCSE Mathematics Foundation Tier Component 1 paper from autumn 2022. This paper is worth 120 marks in total, and this is the fifth video of 6. It will focus on questions 19 to 22, which account for 21 of these marks. Eduqas Component 1 papers are non-calculator, so a calculator should not be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 19. Bryn lives in Canada. When he bought a book from the UK for £240, the exchange rate was £1 is 2.5 Canadian dollars. When he sold the same book to a person in Japan for 162,000 Japanese yen, the exchange rate was 1 Canadian dollar equals 81 Japanese yen. Show that Bryn made more than 1,000 Canadian dollars buying and selling this book. Okay, there's a lot of words there, guys, and we've got two different exchange rates. But what's important here is we're trying to show that he made more than 1,000 Canadian dollars buying and selling this book. So we want both of these values to be in Canadian dollars. Okay, so we're going to start by converting what he spent. Okay, so he spent, and we're dealing with pounds and Canadian dollars. So I'm going to do myself a little proportion table. We know I like those, done those loads in this exam paper. Okay, so we're doing pounds to Canadian dollars. And £1 is 2.5 Canadian dollars. Okay, so we're converting our £240. So that's going to go in our pounds column. So £240 into Canadian dollars. So we want to compare both of these values in Canadian dollars to show that this is true. Okay, remember with the proportion table, we're scaling up or we're scaling down. So we are multiplying or we are dividing. To get from 1 to 240, we've got bigger, so we've multiplied, and we must have multiplied by 240. So I need to do the same to the other side. So I'm doing 240 times 2.5 to find out how many Canadian dollars he spent, okay? So 240 times 2.5. Well, 240 times 2. Well, 24 times 2 is 48. This is 10 times bigger, so it must be 480. And then we want that 0.5. We want half of that. Well, half of 240, we divide by 2. So that's 120. So that's 0, 0, 600. Okay. So he spent 600 Canadian dollars on that book. Okay. Now we're going to find out how many Canadian dollars he sold it for. So we're working with what he sold it for here. Okay, so we're using a new proportion table because we're working with a new exchange rate. So we're doing Canadian dollars. So let's put Canadian dollars to Japanese yen. So 1 Canadian dollar is 81 Japanese yen. Okay, we've got 162,000 Japanese yen. So we're going to scale down this time. We need to figure out what we're dividing by. Okay, so we're going to do 162,000 divided by 81. So that's going to be the tricky thing for us to do here. 162,000 divided by 81. Okay, so we're going to do 162,000 divided by 81. Now, 81 is a small number. So what I'm going to do is I am going to, well, a couple of options here. I'm going to write it as a fraction, okay, to start off with, because I like to work with fractions. You might not, but I do. And then I'm going to use the rules of divisibility, okay. We're going to start with the number 2. Can I divide 162,000 by 2? Yes. Can I divide 81 by 2? No, it's not an even number. Okay, let's start by 3. Can I divide them both by 3? The rule of divisibility for 3 is if you add the digits together and you get a number in the 3 times tables, you can divide it by 3. So 1 plus 6 plus 2. So 1 plus 6 is 7, plus 2 is 9, and then they're all zeros. This adds to 9, so I can divide 162,000 by 3. Let's check 81. 8 plus 1 is 9. 9 is in the 3 times tables. So I'm going to start by dividing them both by 3, guys, okay? And I am going to use this blank space down here. So I'm going to do 162,000 divided by 3. So 3, 6, 9, 12, 15, 18. 3's into 16. 1, 2, 3, 4, 5. Remainder 1. 3's into 12. 1, 2, 3, 4. No remainder, so I need to carry those zeros up, guys, okay? Now I'm going to do 81 divided by 3. 3's into 8, 1, 2. Remainder to get from 6 to 8 is 2. 3's into 21. 1, 2, 3, 4, 5, 6, 7. No remainder, so that gets us 27. Now, these numbers I can deal with a little bit easier, guys, because 54 and 27, 27 is half of 54, okay? So I can divide both of these by 27. So when I divide my bottom number by 27, it's 1. When I divide the 54 by 27, it's 2, but I've got those 3 zeros there, sorry. And then 2,000 divided by 1 is 2,000. So it's 2,000 Canadian dollars that he sold it for. Remember, we were working out Canadian dollars. Okay. We want to show that he made more than 1,000 Canadian dollars buying and selling this book, so we want to see the difference. So we're going to do 2,000 divided by 600. We're comparing the Canadian dollars, guys, which is 1,400. 1,400 is more than 1,000, so we've shown he made more than 1,000 Canadian dollars by buying and selling that book. Question 20A. Tick the two correct statements about this. Okay, so these are the statements we've got to choose from. It's an equation, it's true for all values of x and y, it's an identity, it's only true for certain values of x and y, it's an inequality, it is true for only one value of x and only one value of y. So what we need to look at here is this symbol in the middle. So that's not an equal sign, that's 3 lines. That is the identity symbol, okay? So we've got this here, it's an identity, so I'm going to tick that straight away. And the key thing, if you've got the 3 lines there, the identity symbol, it means that the left-hand side is exactly the same as the right-hand side, and it is true for all values of x and y, regardless of what x and y are. It's true because it's an identity, so I'm going to mark that statement as well. The rest of them are not appropriate for this question. Part B. In this part of the question, all lengths are in centimetres, so that's what we need to recognise that there. So we've got a diagram of a prism here. It's not drawn to scale, so we can't measure anything directly from it. The diagram shows a prism. The cross section of the prism is a triangle with height x and base 3x. So this triangle here is the cross section of the prism. So that's the uniform shape that goes all the way through. So no matter where we would chop this shape down, we're always going to have that triangle shape, a bit like a Toblerone. Okay, the volume of the prism is 216 centimetres cubed. Use an algebraic method to find the height of the triangle. So we're trying to find out what x is, the height of that triangle. They've given us enough information. We just need to form and solve some kind of equation here. Okay, so they tell us what the volume is. So to work out the volume, we would find the area of the cross section. So we would do area of the cross section multiplied by the depth or the other length that they give us. So we would find the area of this triangle and then we would multiply it by 4 because it's that length there that makes this shape then become 3D. So let's find the area of the cross section. It's a triangle. So for a triangle, we do the base times the height and then we half it. So the area of the cross section is 3x times the height, which is x, halved, and then we would multiply it by 4. Okay, x times 3x. So So the volume is x times 3x is 3x squared, still over 2 multiplied by 4. I'm going to simplify this a little bit more. So this is 4 over 1. So 3x squared times 4 is 12x squared. 2 times 1 is 2. And then 12x squared divided by 2 leaves me with 6x squared. So the volume is 6x squared, but we know that that's equal to 216 centimetres. So 6x squared equals 216 centimetres. So I'm going to divide by 6. So 216 divided by 6. 6, 12, 18, 24. 6 is into 21. 1, 2, 3. Remainder 3. 6 into 36. That's 30. 36. 1, 2, 3, 4, 5, 6. 36. So that's 36. Now we need to find out what x is. X equals, well, the inverse of squaring would be to square root. So x equals the square root of 36, which is 6. So the height of the triangle is 6 centimetres. Question 21a. Mary and Paul run 100 metres. Mary's time is between 14 and 15 seconds inclusive. Paul's time is between 12 and 13 seconds inclusive. Complete the inequality to show the least and greatest possible difference between the times of these two runners. So let's compare these times then, okay? So if Mary runs 14 seconds, but Paul runs 12, then the difference is 2. If Mary runs 14 seconds, but Paul runs 13 seconds, then the difference is 1. We're now going to compare if Mary does 15 seconds. So if Mary does 15 seconds, but Paul does 12, the difference is 3. If Mary does 15 seconds, but Paul does 13, then the difference is 2. Okay, so we want the least and the greatest possible distance. So the smallest difference is 1. The highest difference is 3. Part B. Peter wants to go by ferry to France. He's taken a van and a small trailer. He knows the van is 590 centimetres long, correct to the nearest 10 centimetres. The trailer is 200 centimetres long, correct to the nearest 10 centimetres. The ferry company uses the following rules for the length of vehicles. So a small trailer can have a maximum length of 2 metres and a van can have a maximum length of 6 metres. So first thing to note, this is metres, this is centimetres. Okay, we want them to be the same to be able to compare them. So let's do that. 2 metres times by 100 would be 200 centimetres. 6 metres times by 100 would be 600 centimetres. So we've got centimetres and centimetres, which makes me happy. Peter thinks that the length of his van and the length of his trailer will both fit the rules. Use lengths to give one example to show how he may be correct and one example how he may not be correct. So we want a may be correct option and a may not be correct option. So what we're working with here, because it's correct to the nearest 10 centimetres, are upper and lower bounds, okay? So we're going to want the upper bound for the van and the lower bound for the van. And we're going to want the upper bound for the trailer and the lower bound for the trailer. So the highest possible length it could be and the lowest possible length it could be. And then we can look at all different options. So upper bound for the van. Well, if it's rounded to the nearest 10 centimetres, we half this and that's what we take off or add on to get our upper and lower bounds. So 10 divided by 2 is 5 centimetres. So for our upper bound, 590 plus 5 is 595 centimetres. For our lower bound, 590 subtract 5 is 585. Okay, we're going to do the same with our trailer now. 200 centimetres to the nearest 10 centimetres. So we're adding on and taking off 5 for our bounds again. So our upper bound will be 200 plus 5. Ooh. And our lower bound would be 200 subtract 5. Okay, so everything's in centimetres here. So we're looking for a combination of these things that may be correct and may not be correct. Okay, so the maximum length of the van and the trailer together, so 600 plus 200 is 800 centimetres. So we're looking for a combination of upper bounds and lower bounds that might be correct, so that gets us less than 800, or may not be correct, it gets us more than 800. Okay, so the may not be correct is more than likely going to be if the van and the trailer are at their maximum length. Okay, so maximum length. So let's highlight this, may not be correct if we're dealing with the upper bound of our van and the upper bound of our trailer. Okay, so let's try that. Upper bound of our van, so maximum length of the van is 595 plus the max length of the trailer, which is 205. Well, 595 plus 205 equals 7. 800, so this may not be correct because we're pushing it very much to the limit of the maximum, okay? But it may be correct, let me get a different colour. It may be correct if we use our lower values, okay? So if we have our lower length of our van and our lower length of our trailer, it may fit within that 800. So minimum length of the van is 585, and then we're going to add the minimum length of the trailer, which is 195. So 585 plus 195. 5 plus 5 is 0. 9, 18, 780. So that could work because it's less than 800. So we've given two options. It could be correct if the length of the van and the trailer are the lowest they could be, but it may not be correct if the length of the van and the trailer are the maximum they could be, because it will push it right to the limit of the maximum length on the ferry. Question 22a. Work out 6 times 10 to the power of 5 divided by 20. Give your answer in standard form. Okay, the first thing we're going to do is we're going to convert 6 times 10 to the power of 5 into an ordinary number. So 6 times 10 to the power of 5, 10 to the power of 5 would be 100,000. So we're doing 6 times 100,000, so that's 600,000. So we're doing 600,000 divided by 20. So 600,000 divided by 20. So I'm going to divide top and bottom by 10. So then I'm doing 60,000 divided by 2, which is 30,000. So I'm just halving it. I want my answer in standard form. So standard form needs to be a number between 1 and 10 multiplied by 10 to a power. Okay, so I am going to multiply by 10 to a power. My number between 1 and 10 is going to be 3. And to get from 3 to 30,000, I need to multiply 3 by 10,000. So 10,000, 1, 2, 3, 4. So that would be 10 to the power of 4. So that's my answer in standard form. Part B. At midday, the volume of water flowing over a waterfall, so this is at midday, is 3 times 10 to the power of 8 litres per minute. At midday, what is the volume of water flowing over the waterfall in litres per hour? Give your answer in standard form. Okay, so we're given 3 times 10 to the power of 8 as litres per minute, but we're working in litres per hour. So we're going to want to multiply by 60. There are 60 minutes in an hour, okay? So you want to multiply that by 60. Well, 60 times 3 is 180. 180 times 10 to the power of 8. Now we want our answer in standard form. Standard form is a number between 1 and 10 multiplied by 10 to a power. 180 is not a number between 1 and 10. So we are going to have to divide 180 by 100. Which would give us 1.8, which is between 1 and 10. But because we've divided by 100, that means we'd need to multiply by another 100 on the end here. So we'd have 10 to the power of 8 times by 100 to get it back to its original value. But we want it to be 1.8 times 10 to a power. Well, 100 is 10 squared. And then if we use our laws of indices, 10 to the power of 8 times 10 to the power of 2, we add our powers. So it becomes 10 to the power of 10.